Okay, so let's begin. Last time we were discussing we started to discuss nonlinear oscillations, di ba? And dun sa discussions na yon, basically ang ginawa natin is discuss tayo ng isang example at pinakita natin yung example na yon ay can be described by a nonlinear by a force that is nonlinear, that has a nonlinear component, okay, yung x cube na component, okay? And then tinignan din natin yung corresponding na tawag dito, potential tsaka force diagram, and then tinignan natin yung phase plot nung tawag dito nung nonlinear potential na yun. Then, okay, towards the end, may isa kayong kaklase na nagtanong paano kung meron ng damping. Hindi natin consider kasi yung damping doon, di ba? Yun yung i-discuss natin ngayong araw. Okay? Ano mangyayari pag yung nonlinear oscillation ay dadagdagan natin ng damping? Recall na yung equation natin for damping, titignan niyo yung notes. Okay, dun sa third term, sa second term, okay, yung damping is actually expressed in terms of a function that is dependent on the velocity or a function that is dependent on x dot, right? Okay, so and yun yung introduce natin ngayong araw. So to describe a system that has damping, we are going to describe a specific system which is called the van der Pol system. At yung corresponding na van der Pol equation is given by this equation. So x double dot plus mu x squared minus a squared x dot plus omega naught squared x is equal to 0. Okay? Yung mu a ay mga parameters. Okay, mu is a small positive parameter. Okay, which we will see kung ano yung magiging effect mamaya. And of course, yung omega naught, alam naman natin kung ano yung omega naught. It relates to yung spring constant. Okay? Spring constant at saka yung mass ng system. Now, there are two things that can happen here. If yung amplitude, so tignan niyo yung middle term, x squared meron tayong x squared minus a squared na term. Right? So kung halimbawa, so case 1, kung halimbawa yung absolute value ng x greater than the absolute value of a, then we have a damping that is yung typical. Okay? So ang tawag natin, ang value ng middle term is positive. Di ba? And yung damping na mangyayari is yung familiar tayo dun sa discussions earlier na yung amplitude niya bababa lang. Okay? So yun yung typical na damping na inaano natin. And then sa case 2, ang case 2 is when x, absolute value of x is less than the absolute value of a, then we have negative damping. Okay, so ano ibig sabihin ng negative damping? Ang alam natin na damping is when you apply a damping force, syempre yung amplitude ng oscillation is liliit, right? But what is negative damping? In this case, ang behavior ng system, kung meron kang negative damping, is yung amplitude lalaki. Okay? Imbis na nagle-lessen yung amplitude, palaki ng palaki yung amplitude. Okay? Now, it's not easy to identify a physical system na familiar tayo na merong negative damping. Tama ba? Makakaisip ba kayo ng system na tawag dito, nag-exhibit ng negative damping? Ano? Pero dito sa equation na to, wala siyang driving force. So yung sinasabi mo, yung motor, yun yung driving force. So dito, yung right-hand side is 0. So wala kang driving force. Okay, pero it's good that you're thinking about it. Okay, so ano pa?
Parang wala sa energy ka na create.
Yes, yes. Yeah, it seems na ano, 'di ba? It seems na anong tawag dito? Na this is a violation of conservation of energy. Okay? Um anong tawag dito? So yun. So hindi siya typical na behavior, but still theoretically it's still something na ano na maganda lang tignan. Okay? Now ano tong figure na nandito dito? Ang figure na nandiyan is a phase diagram. Okay? Now if x is equal to a, then wala kang damping. Di ba? The absolute value of x is equal to a, then wala kang damping. So what you have is a behavior, okay, that is limited dun lang sa dun lang sa specific na ano ba na shape, okay, nung x dot versus x, okay. So dito yung shape na yon is a circle. Okay? So kung titignan niyo rito, yung dark portion, yung dark part ng circle, yan ay test pa rin ah. Okay, yung dark part ng circle, yan yung x, absolute value of x equal to a. Okay? And yan yung alam natin na behavior before. Okay? Na pinag-aaralan natin na behavior before. Okay? So ang tawag natin dyan is the limit cycle. Okay? So paikot-ikot lang siya ng ganyan. Now, if x is greater than a, ibig sabihin, yun yung typical na damping, then ang tinitignan nating behavior dito is yung nasa loob. So, ang nangyayari is lumiliit ng lumiliit yung amplitude. So from the limit cycle, okay, yung amplitude niya nagdi-decrease. Pero syempre yung amplitude niya nagdi-decrease in this manner. Okay? Ay hindi, sorry, baliktad. Sorry. Etong nasa labas yung ano, yung x greater than a. Okay? And makikita naman natin dito kasi may arrow. Papansin niyo ba yung arrow? Okay, so yan yung mga arrows na naka-point towards the limit cycle. So lumiliit ng lumiliit yung amplitude until it reaches the limit cycle. Okay, so ang behavior niya is inward. Okay, so nagsa-spiral siya inward. Okay? What about if absolute value of x is less than a? So ibig sabihin lumalaki yung amplitude. So if a particle starts from a velocity that is 0, for example, at yung position niya is this, ang mangyayari is mag-increase yung kanyang amplitude, di ba? And it spirals outward, okay, towards the limit cycle. So yun yung biging behavior. Okay. Okay, so sige, let's see. Ay, sa iPad pala ako. So, pause ko muna tong video. So, yan yung nakita natin kanina. Okay. Okay? So, para lang na naintindihan. Again, alam niyo kaagad kung ano yung initial position. This corresponds to x equals 1, this corresponds to x equals 2, and this corresponds to x equals 3. Okay. Any questions? So, I hope nasagot ko yung tanong mo tungkol sa damping. Okay. Any questions? So, now, ang i-discuss natin is a plane pendulum. Okay, so, plane pendulum, of course, is behaves in an oscillatory manner. Diba? Alam naman natin yun. But typically, ang pinag-uusapan, when we discuss plane pendulum, ang tinitignan na natin ay yung nandun sa near the equilibrium position. Diba? And bakit near the equilibrium position? Kasi near the equilibrium position, we have wait. Near the equilibrium position, dali hindi ito yung slides na pinipare ko na kanina. Shoot. Okay, so, sandali lang. Save ko lang to. So, para hindi mawala yung pinagsusulat ko dyan. So, close ko. Save. Sino si Ned? Hindi, nakalagay lang Ned's MacBook Air. Okay. So, ito yung ito yung na-prepare ko na slides. So, okay. Actually, ang gusto ko ipakita is this. Okay. So typically ang ginagawa natin, di ba? We have this differential equation, theta double dot plus omega naught squared sine theta is equal to 0. Di ba? Yan yung differential equation that describes the simple pendulum. And of course, hindi straightforward na i-solve yung differential equation na ito dahil dun sa sine theta. Kasi meron kang trigonometric function. So ang ginagawa natin is we use a small angle approximation. Okay, and if we do that, then we end up with omega naught squared theta is equal to 0. Kasi ang small angle approximation, sine theta is equal to theta. And from your Physics 101.1 experiment, so yung small angle ngayon corresponds to any angle less than 10 degrees. Okay? And in this case, linear yung behavior ng force. Okay? Kasi yung force dito is proportional to sine theta. And if you do small angle approximation, then yung force na yan is magiging proportional na sa theta. Kaya kung titignan niyo yung graph, yung force is, pag small angle approximation, then you have this linear approximation na nandun sa graph. Okay, yung dash line. Pero if you don't do the small angle approximation, then yung force is sinusoidal. Okay, now that's what we want to discuss now. So we're moving away from the linear approximation, and we're going to try to describe kung ano nangyayari sa anong tawag dito dun sa actual, okay, sa actual na equation. Okay, and ano yung unang magiging implication nito? Ano yung experiment niyo sa 101.1 that is related to this? Kailan ba yun? Parang last year lang yun anong experiment niyo sa 101.1? Last year pala para sa iba. Ano na? Yung iba, 20 years ago. Sino kaya yun? Ano experiment yan? Siyempre, yung experiment about pendulum. Diba? Ginawa niyo ba yan? Ay, online kayo.
Projectile.
Ay.
Bullet, sir.
Dinideserve nyo ngayong pizza. Well, dun sa experiment na yon, okay? Dun sa experiment na yon ay ano tawag dito? Pause ko muna to kasi wala. Hindi, sige, pakinggan nyo na lang para at least alam nyo kung anong visualize. So dun sa experiment na yun, merong pendulum. Okay? Anong ginawa nyo? Bola na nagbabounce lang? Project kayo din? Kayo din? Tabutan nyo? Wala. Ikaw? Okay, ikaw?
Iba sir, sister, ano din po.
Pero nag-pendulum kayo.
Hindi po.
Hindi ko ata.
2 years ago.
2 years ago, ano yun? Pandemic yun. So ganun, so nagbabawas din yung amplitude. Anong mini-measure ninyo?
I-measure yung parang range, tapos yung distance, tapos i-calculate yung force na nagkakit para gamitin yung projector.
Asa ang oscillatory motion?
Wala.
Asa ko natin experience sa oscillatory motion? Okay.
Walang discussion.
May pagkaiba.
So dun sa experiment, tawag dito, just sa mga experiments sa 1.1, is meron talagang pendulum. So may string and then may bar. Okay? Tapos, mag-swing yun. Okay? And then, papalitan yung length. Tapos i-measure nyo yung time. Okay? Ginawa nyo ba yun sa high school or? Okay, so, essentially, 2 pi square root of L over G. Kung tama yung, or G over L, kung tama yung memory ko. L over G or G over L?
L over.
Okay. Huwag mo muna picturean kasi hindi ko alam kung sure yan. Okay. So, papalitan niyo yung length ng L, and then ang mini-measure actually dito is yung period. So, habang nagsiswing ng ganyan yung pendulum, pag regular, syempre, ang bilis ng period niya. Diba? And yung period is one swing. Diba? Tapos, magsa-start lang sa angle na 10 degrees. You can see yung small angle approximation. Tapos, papahabain yung length niya. Siguro mga 5 times yung papahabain, tapos puro 10 degrees yung starting, and then magkakaroon ka ng iba't ibang period. And then, i-graph mo ngayon yung tawag ito, period versus L. Okay, makakuha ka ng, or period versus square root ng L, makakuha ka ng linear na graph at ang slope niya is 2 pi over G. And then from there, makukuha niyo yung acceleration due to gravity. Okay, pero ang point ko dun is, yung mini-measure dito is yung time. Yung mini-measure dito is yung time. Now, and everything is measured under the assumption na ng small angle approximation. Okay? Now, if we increase that angle, that initial angle greater than 10 degrees, then obviously wala na tayo sa small angle approximation. What do you think will happen to the period? Tatagal, di ba? Tatagal. Okay. So, by how much will it increase? Okay? Yun yung i-discuss natin ngayon. So, ito try nating i-derive yung period without the small angle approximation. And we're going to do that using elliptic integrals. Saan nyo narinig ang elliptic integrals? 1 to 1. Okay. Okay, and then sa elliptic integrals, ang diniscuss nyo dun ay simple pendulum din, di ba? Tama ba? Kung naalala nyo or hindi. Okay. So ang idea is this. So ang pendulum of course is swinging in this way, and then yung bob yung trajectory niya is circular, okay? At this point, okay, dito sa point na ito, yan yung point na kung saan zero yung potential at maximum yung kinetic energy. Okay? And dito sa point na ito, yan yung point na kung saan anong tawag dito? Zero yung kinetic energy and maximum yung potential. Okay? Of course, pwede naman natin paabutin pa, paakyatin pa. Okay? Pero syempre mas madaling mathematically pag nilagay lang natin. Okay? So, ang angle na yan is 90 degrees. Right? Okay, pag zero yung kinetic energy at maximum yung potential. Okay, so anong gagawin natin dito? As always, ang una nyo pa natin gagawin is you set up the equations of motion. And to do that, you have to identify yung forces acting on the object. Okay, anong forces na nag-act dito? Okay, gravity. May tension. Yun lang, no? So, gravity pababa and then tension in this way. Okay? Now, mg. Okay. Now, between these two forces, alin yung nagko-cause ng swinging behavior? O ganito na lang, i-revise ko yung question. Does the tension contribute to the swinging behavior? Or does tension contributes to the torque? Kasi nagro-rotate siya. Diba? Hindi, dahil walang component ng paano bang direction ng motion niya? Pero syempre at that point ang ginagamit natin na line is tangent, di ba? So sinasabi natin na tangential yung force na yan. Okay? So yan yung force na nagko-cause ng rotation. And makikita nyo since perpendicular yung tension dun sa force na yan, okay, walang contribution yung tension dun sa force. Okay? Now yung force na yan obviously may component dun sa yung force, yung weight ay may component, or actually yung weight is the force, okay, that causes the circular motion. Pero it's not the whole weight but only a portion of the force. Okay, so component lang ng force. So if this is angle theta, then ibig sabihin ito rin yung hindi yan yung angle ng theta. Ito yung angle ng theta. Okay, yan yung angle ng theta. Okay, so ibig sabihin yung component nung force na nagko-contribute sa swinging motion is mg sin theta. Yun na yung mg sin theta. Kaya kanina sinabi natin na proportional siya sa sin theta. Yes. Okay na? Just let me know kung merong hindi clear para ano. Okay? Okay, so syempre, i-set up na natin yung equation. So sum ng forces, okay, naglagay tayo ng coordinate system. Okay, ito yung positive y, and then of course gusto natin na ito yung positive x. So along the x-axis, we have mg sin theta is equal to mx double dot. Okay, now, ito yung konting complication kasi we're describing things in terms of theta sa left-hand side, pero yung sa right-hand side, it's in terms of position. So, theta is, of course, angular, di ba? We use theta when we describe angular motion, and x we use when we describe linear motion. So, how do we relate x sa anong tawag dito? How do we relate linear to angular? Naalala nyo ba? So, halimbawa, yung linear displacement is related to the angular displacement by what parameter? Minsan mahirap pag words eh. Pero pag sinusulat natin in letters, linear displacement is related to angular displacement in terms of sige, radius. Ano equation? S equal to r theta. Di ba? Di ba? O bumabalik na ba lahat sa inyo? Gawin na lang natin itong x kasi x yung ginamit natin ng linear. And of course, if you take the derivative of that with respect to time, and r, nandiyan na ba? Sige, pakitulungan naman si... Okay. Ay shit, hindi ako nagre-record. Pinos ko ba?
Yes.
Hindi ba? Okay. Shit. Ay, hindi ko nga. Okay. Nahuli din yung pagmura ko. Sige. Yung R ba rito nag-change with respect to time as it swings, yung radius? Oo. Hindi naman yung spring, yung length nung, di ba? Yung R dito is yung length nung string. Right? Okay. Of course, masaya yon kung nagbabago yung, di ba? Mga ganun-ganon. Pero, Masaya tignan, pero mahirap isolve. Right? Masakit isolve. Okay. So ang kukunan na natin ng derivative ay yung angular displacement with respect to time. And of course, yung second derivative nito will be r times theta double times. Okay? Okay. So yung ating equation of motion will then become mr theta double dot equals sa mg sine theta. Okay, and then syempre magka-cancel yung m, then we end up with theta double dot is equal to g over r sine theta. Okay, and of course we say so theta double dot minus g over r sine theta is equal to 0. Okay, and then sinasabi natin ay omega naught squared is omega naught squared is g. Okay. So that's one way to set up yung anong tawag dito, yung equations of motion. Now another way is to use lagay mo muna sa harap mo. Birthday mo talaga ha. Pag chinek ko sa size 3. Okay. So anong tawag dito? That's ang sinasabi ko, this is one way to determine yung equation of motion. Okay? Now, there's something missing dito sa equation of motion na to. Makikita natin kung ano yung kulang na yan if we treat it in another way. So what we're going to do is we're going to use energy considerations, so specifically conservation of energy. Okay? Now, sa conservation of energy, okay, yung kinetic energy, yung change in kinetic energy, let's say from here to here, okay, nag-i-increase yung kinetic energy, di ba? Di ba kasi sabi natin, dito zero yung kinetic energy, dito maximum yung kinetic energy. Okay? And dito, ang kinetic energy is described as 1/2 mx squared, which is just mr theta dot squared. Tama? Okay. Now, what about yung potential? So this is delta K. What about yung potential? Of course, this is minus 0. Kung isipin niyo minus 0 yan kasi we started from it. So from this position, okay, to this position, ano yung potential dito? Dito, yan yung potential dyan. Maximum, di ba? So, ano yung equation ng potential? mgh. Ano ang h dyan? Siyempre, kailangan nyo describe in terms of theta. Right? So, ang initial niya is mg sine, let's say theta m, which corresponds to theta max. Okay? And sa figure na to, yung theta m is 90. Yung theta m dyan is 90. Okay? Then, of course, negative yan. Ano? Ha? Ha? Nagano? Hindi, wala. Negative sign lang, hindi talaga siya sumulat. Okay. And then, pagdating dito, dyan, you have, or sorry, hindi necessarily dyan, anywhere, di dyan. So, yung potential dyan is mg sine theta. Okay, anywhere dun sa trajectory. Okay? Okay, so pwede kong isulat as mg, teka, asan yung h? Yung r, di ba? Yung r. Dapat may r to. Okay. Mg r sine theta sub m minus sine theta. Okay? So yan yung delta U. which means now we have 1/2 mr theta dot squared is equal to negative mg r sine theta sub m minus sine theta. Cancel yung m.
Kasi
Ha?
di naging positive, sir.
Alin? Hindi, yung sine theta sub m nasa pinagbaliktad ko yung
Kasi pero negative delta yun, sir. Ay, pinag-equate niyo na po ba yun?
pinag-equate ko na sila.
So, di po ba magpa-positive yun?
Hindi, sorry. Dapat ito negative yan. Dapat negative. Yes. Kasi dapat yung change is decreasing, di ba? So nagdi-decrease dapat yung potential from this point to this point. Right? Yes, dapat nagdi-decrease yung potential. So kaya negative change yung pinag-uusapan natin. Okay, so ano pa yung magka-cancel? Yung R. So ang matitira is theta dot squared is equal to negative 2G. Sandali tinutry ko lang i-reconcile yung mga signs. Okay, sige. Never mind. 2G. Sandali, may kulang.
So yung equation for the potential. In terms of
Oo.
ay sin theta sir.
Oo.
Or sin of 0.
Right. Tama. Ngayon, ang nawawala dito is yung ano. Ang nawawala dito is yung R. Cosine theta sub m minus cosine theta. And then cosine theta sub m minus cosine theta. Okay. May kulang ako na R. Saan ako nagkulang? Of course. Ayan. Kasi velocity squared di ba? Velocity squared. So R squared dapat yan. 2G over R. Okay? Okay, so cosine theta sub m minus cosine theta. Okay. Now we'll start with that. So if we take the square root of that, so meron tayong d theta dt is equal to plus or minus 2g over r square root, and then cosine theta minus cosine theta sub m. Okay, pinagbaliktad ko ulit yung cosine theta at cosine theta sub m para ma-accommodate ko lang yung plus or minus sign dun sa square root. Okay, from there to there. Okay? Okay lang? Okay, so ito yung ating working equation. So when t is equal to 0, okay, theta is equal to 0. And then at any time t, let's say t prime, okay, theta is equal to theta sub m. Okay, ginawa natin yan kasi para ma-integrate natin. Okay? So pag nag-integrate tayo, okay, etong part na ito, syempre ibababa natin yan doon, di ba? At itong part na ito, iakyat natin doon. Right? Right? Okay. So so cosine theta minus cosine theta sub m raised to the negative 1/2 d theta integral. Okay, so at t equals 0, theta is equal to 0, and at t equals, at any time t, then theta is equal to theta sub m. So ito ay equals to plus or minus 2g over r raised to the 1/2, and then t equals 0, and then t at any time. It's dt prime. Okay. Okay. Now, if we are considering, dami ko nang pinagdo-drawing dito. Ito na lang yung may glitters. Ito yung t equals 0, sabi natin, di ba? T equals 0, theta is equal to 0. And then yung t prime is theta sub m. O, limbawa, ito ang ating theta sub m. So that's just 1/4 cycle. 1/4 of a cycle. Tama? Kasi aakyat pa lang siya eh. 1/4 lang yan. Ito yung pangalawang 1/4. Ito yung pangatlong 1/4. And then ito yung pang-apat. Yan ay isang buong period. Right? Right? So if we think that we're doing that, okay, then yung period na kino-compute natin dito, yung period na kino-compute natin dyan is just 1/4. O yung time, sorry, yung time na kino-compute natin dito is just 1/4 of the period. Okay? Okay? So later on magkakaroon tayo ng well, kahit na hindi na later on, kahit ngayon na, tau over 4. So, napipizza na kayo, no? Tau over 4. Yung tau dito is yung period. Okay. So, pwede ko nang ilipat yung coefficients ng tau sa kabilang side. Right? Pero hindi pa rin natin nasosolve yung integral, r. R over 2g is the 1/2 integral from 0 to theta sub m. Cosine theta minus cosine theta sub m negative 1/2 d theta. Okay, so we're going to use yung trigonometric identity. Cosine of x is equal to 1 minus 2 sine squared x over 2. Okay, para i-rewrite yung integral. Okay? So ito, papalitan natin yan ng 1 minus 2 sine squared theta. Ito, papalitan natin ng 1 minus 2 sine squared theta sub m. Okay? So tau is then equal to 4 r over 2g raised to the 1/2 theta sub m. Okay. 1 minus 2 sine squared theta over 2 minus 1 minus 2 sine squared theta sub m over 2 tapos negative 1/2 d theta. Siyempre magka-cancel dyan yung 1. Tama? And we are left with 2 sine squared theta sub m over 2 minus 2 sine squared theta over 2. Yes, questions? Ay, nawawala pala siya. So, we have tau is equal to 4 r over 2g is to the 1/2. And then if I factor out ko yung 2 at yung sine squared theta sub m over 2. Okay, and remember, nasa denominator siya. Kasi negative 1/2 yan eh. Negative raised to the negative 1/2. Okay? So when I factor out 2, I'm actually factoring out 1 over square root of 2. Okay? So 1 over square root of 2 dito. 0 theta sub m. Okay, sige, para hindi nakakalito, ilalabas ko na lang na ganyan. Theta sub m over 2. Then 1 minus sine squared theta over 2 over sine squared theta sub m over 2. Then yung d theta sa taas. May square root ito. And then since wala na yung square root sine theta sub m. Okay? Okay, now, bakit natin ginagawa ito? Aside from papahirapan natin sarili natin. Kasi eventually, at some point, gagamit tayo ng pwede tayong, hindi pala tayo gagamit. Okay, iniisip ko magbabinomial expansion tayo, pero hindi pala. Well, it will make things easier pagdating sa integration. Okay, so, let's see. Gagamit tayo ng isang well-known technique sa Math 53, 54, yung let you technique. Let you be equal to sine squared sine theta over 2 over sine theta sub m over 2. Okay. So, ibig sabihin, ang du is equal to constant lang yung sine theta sub m over 2, ah. So, 1 over sine theta sub m over 2. Okay. With cosine theta over 2. Tapos, meron pang coefficient na 1/2. Ay, ba yan? Okay. Ay, nakalimutan ko yung d theta dyan. Okay na? Okay? Okay. So, syempre, i-replace na natin lahat yan doon, ano? Bago natin i-replace yan, papalitan muna natin yung limits of integration. Pag ang theta is equal to 0, ano ang u? From here, yung okay, u is equal to 0. Okay. And pag theta is equal to theta sub m, ang ui, pag theta, replace yung theta by theta sub m, u is equal to 1. Right? Right? Kasi sine theta sub m over 2 divided by sine theta sub m over 2. So equal yan sa, hindi mas malinis na tignan yung integration natin kasi 0 to 1 lang siya. Okay, now, ito pampansinin ninyo, meron akong d theta sine theta sub m dito. Remember, we're going to replace that with sine, ano tawag dito? du. Tapos meron din akong d theta over sine theta sub m dito. Okay? So na-replace ko na partially. And yung cosine theta over 2, gusto kong gawin ding u yan. Diba? Gusto ko rin siyang gawing u. Okay? So anong mangyayari dyan? So ano ba ang cosine? So from here, from here, sine theta over 2 is equal to u sine theta sub m over 2. Which means na ang cosine theta over 2 is 1 square root ng 1 minus sine squared theta over 2. Di ba? So square root ito ng 1 minus u squared sine squared theta sub m over 2. So yan yung ipapalit ko dyan. Ayos? Okay? Pwede na. So ngayon yung tau natin magiging equal sa 4r over 2g square root 1 over square root of 2 evaluated from, integral from 0 to 1. Okay? Ng 2 du, yung 2 galing dun sa 1/2 ng cosine. Okay? 1 minus u squared sine squared theta sub m over 2. Ito yung cosine theta over 2. Okay? And then yung 1 minus u squared the 1/2. Napadali ba yung ano? Ma-integrate nyo na ba yan? Di pa? Ano yan? Pwede ilabas yung? Pwede naman. Actually, magka-cancel na lahat ng, mawawala na lahat ng 2 dyan eh. Diba? Kasi may 2 ka sa taas, and may dalawa kang square root of 2. Diba? Sa baba. Okay. Yes. Pero may integrate na ba natin yan? Hindi pa. Hindi pa, di ba? Actually, yan na yung elliptic. Yan na yung elliptic integral. Yan na yung elliptic integral. Well, almost. Almost. Hindi pa yan yun. May isa pa tayong transformation na gagawin. Okay. Yung isang transformation na gagawin is yung u, gagawin nating sin phi. Okay, yung u ay gagawin nating sin phi. Okay. So pag pinasok natin dyan, magkakaroon tayo ng sin squared phi. Right? Tama? Okay. And ang 1 minus u squared square root is 1 minus sin squared phi. Square root nun is cosine phi. So ito ay cosine phi. Right? Okay. Yung du na lang ang intindihin natin. Du is equal to cosine phi. Buti pa yung pusa, ang bilis sumagot. d phi. Yung du na yan ay cosine phi d phi, right? So pwede ko na i-cancel yung mga 2 na to. Okay. May cosine tayo sa baba, may cosine tayo sa ilalim. Okay, magka-cancel yan. Okay? Yes. So yung tau natin ngayon will be 4 r over g raised to the 1/2 0 to 1 ng d phi all over 1 minus sine squared theta sub m over 2 sine squared phi. Yan na yung ating elliptic integral of the first kind. Pag nasa taas yung naka-square root na yan, pag nasa taas yan, yun yung elliptic integral of the second kind. Okay. Now, gagamitin natin yung expansion, yung series expansion. Okay. Anong i-expand natin? I-expand natin yung f of sine squared. Actually, expand natin yung buong square root. Okay, about sine squared theta sub m over 2. So sine squared phi. So remember, yung function ay yung square root. Yung square root. So negative 1/2 to. Okay, yung function dito yung square root. So we're going to expand the function about sine squared theta sub m over 2. Okay? And we're going to expand that. Actually, we're going to expand that for sine squared theta sub m over 2 equals 0. So this is a Maclaurin series. Okay? Usually kasi sinasabi natin, okay, we're going to expand at x equals 0. Pero wala tayong x dito eh. So ano yung dependent variable na kung saan mag-expand tayo over or about. So ang dependent variable dito is actually a trigonometric function which is sine squared theta sub m over 2. Okay? So I hope that's not too confusing. So this is an expansion. This is simply a binomial expansion about 0. Okay, now in the interest of time, and siguro para ma-practice na rin kayo, sulat ko na yung expansion. So, f at sine squared theta sub m over 2, 1 plus 1/2 sine squared theta sub m over 2 sine squared phi plus 3/8 sine to the 4th theta sub m over 2 sine to the 4th phi, and so on and so forth. So which means na yung ating period is 4 r over g raised to the 1/2. Okay, by the way, hindi natin kinonsider yung limits of integration. If u is 0, ano ang phi? If u is 0, anong phi? Ito lang yung equation namin. 0. Okay. And if u is 1, okay, kasi yun yung upper limit, di ba? U is 1, ang phi is pi over 2. Okay. So yung ating integral dito will be, integral natin is 0 to pi over 2. Right? And then yung expansion, 1/2 sine squared theta sub m sine squared phi plus 3/8 sine to the 4th theta sub m over 2 sine to the 4th phi plus and so on and so forth ng d phi. Ang problema nyo na lang ngayon is paano integrate. Kasi term by term, merong sine to the 2n theta d theta. Diba? Or sine to the 2n d phi. In other words, ito yung kailangan integrate. And of course, that's from 0 to pi over 2. Nalala nyo ba ito o hindi? Malamang hindi, no? Double factorial pi over 2. Nalala nyo kung anong double factorial? Mag-skip kayo ng 2. Diba? So, alam mo, 2n double factorial is 2n times 2n minus 2 times 2n minus 4 times 2n minus 6. Ganun. Kaya yun lang yung ibig sabihin ng double factorial. O, hanggang sa 2 and then yung 2n minus 1 double factorial is 2n minus 1 times 2n minus 3 times 2n minus 5 hanggang sa 3 times 1. Okay, so yung first term ngayon ng integral is Ano yung first term ng integral? Integral ng d phi, di ba? From 0 to pi over 2. So ano sagot? Pi over 2.
Dito ba raise to 1/2 yung C?
Raised to 1/2 yung? So ibig mo sabihin negative ano? Dapat may negative ka diyan somewhere, no? Yun yung point mo ba? Ano yung gusto mong sabihin?
Nawala yung 1/2.
Anong nawala yung 1/2 exponent?
Sa tao.
Ah? Saan yung 1/2?
May one.
Some... Dito? Eh. Alin dyan? Pwede bang ang hirap gumalaw? hindi ako maggalaw kasi pag gumalaw ako nawawala eh. Pakituro niyo na lang. Lapit ka na tutunod.
Ito, sir.
Saan ang problema dyan?
Sir, nawala siya.
Nawala siya saan? Naging negative 1/2 siya. Ano siya? Negative 1/2 siya. Pag in-expand nyo, actually, yung second term is 1/2. Actually, dapat alternating yata ito eh. Dapat kasi negative 1/2 siya. No? Hindi siya alternating kasi minus sine squared ano siya, di ba? Ito. Yan, may minus sign kayo diyan. Okay? So, ang first term dito actually is 1, di ba? Which is yung tama. Ang next term dito is negative yung negative 1/2, di ba? Yun yung magiging coefficient niyo pag kinuha niyo yung derivative, di ba? Pero may negative sign squared ka kasi dito, yan. May negative sign squared, so magiging positive siya. Okay? And then yung next term, so di ba yung denominator niya after you take the derivative magiging negative 3/2. Di ba? And then pag kinuha niyo yung derivative doon, magiging negative 3/2 siya. Times 1 over 2 factorial ba yun? Or ano? Kaya 3/8. Doon galing yung 3. Okay, kaya kasi may negative 3/2 kayo. So kaya yan. So nandiyan pa rin siya. Except yung video feed natin wala na. Ay. Kailan mo tayo magkakaroon ng matinong ano? Okay, so asan na tayo? So pi over 2. Then yung next term is remember yung sine squared theta sub m is over 2 is a constant. Di ba? So nandiyan lang siya. Sine squared theta sub m over 2 is just there. Okay, and then ang sine squared phi, integral ng sine squared phi is, so ano ang n natin dyan? Ang n is 1, di ba? Ang n is 1. So 2 times 1 from grade 2. 2 times 1? 2. Minus 1? 1. Okay. So 2. So yung numerator ay 1. Yung denominator ay 2. So 1/2 times pi over 2. So pi over 4. Right? Pero may 1/2 ka pa na coefficient. So pi over 8. Ang galing ah. Dapat nag-move ka forward. Habang sa bawat tamang sagot.
May star.
Oo, may star. So, theta sub m over 2. Okay, and yung coefficient na makukuha nyo dyan ay 9 pi over 128. And so on and so forth. Okay. So pag factor out natin, if-factor out natin yung pi over 2, so we'll end up with 2 pi square root of, yung r gagawin kong L, 1/2. Tapos 1 plus 1/4 sine squared theta sub m over 2 plus 9 over 64 sine to the 4th theta sub m over 2. So on. Okay. Now, if we use the small angle approximation, meaning yung theta sub m is small, what do we end up with?
2 pi.
Okay, for small theta sub m, which is yung original expression natin for the period. Diba? Saan ko ba banda nilagay yun? Dito. Right? Right. So, eto ngayon yung period na nagde-describe ng, anong tawag dito? Well, we can say na exact solution kasi hindi tayo gumamit ng small angle approximation. Now, we can see that, of course, depende sa angle, magiging malaki yung contributions ng mga second, third, at saka fourth term. So yung period, tulad ng sinabi nyo kanina, hahaba siya. Right? Okay. So, ayan, nabanggit ko lang yung experiment ko sa 101.1 kasi I don't know kung, hindi ko na maalala kung pinapagawa pa yung angle greater than theta, angle greater than 10 degrees. Pinagawa ko ba yung before? Matagal na nga ako hindi ko nga maalala. So, kasi pag pinagawa mo na yung angle greater than 10 degrees, of course, and then you use yung equation na to, 2 pi square root of L over G, magkakaroon ng error. So, ang tawag dito, ang isang question, typical na question is, di ba, account for errors. Okay? So, itong second, third, fourth term, succeeding terms, yan yung isang source ng error. Yung approximation. For angles greater than 10 degrees. Okay. Yeah, so yan yun. Now, ano pa yung ibang paraan para i-describe natin ang behavior ng system? So dito, dinescribe natin siya in terms of period, di ba? So nakita natin na when it's exact, the period becomes longer. Ano pa yung ibang paraan para i-describe yung anong tawag dito? Yung behavior ng system? Phase diagram. Okay, phase plot. Okay. So saan natin kukunin yung phase plot? Siyempre, we're talking about dito, angular displacement. So yung x-axis natin is angular displacement, which is theta. Diba? Okay. At yung y-axis natin ay
Theta.
Theta dots. Diba? Angular velocity. Okay? Okay. And this is what the phase plot of the simple pendulum looks like. Yan. Ang saya, di ba? Well, yung dark portions diyan, yung darker lines, yan yung limit cycle nila. Okay? So yan yung typical behavior. Okay, when E is equal to E naught. Ang E naught dito is 2 mgl. Okay, 2 mgl so meaning yung cosine is cosine theta is 1. So ibig sabihin theta is 90, diba? So nag-swing siya. Nag-swing siya ng pagganyan, vertical. So ganyan. Pag ganyan yun yung limit cycle. Okay, now if yung energy is less than E naught, okay? So ibig sabihin, pag E is less than E naught, ang tinitignan ninyo, hirap mag-English, something like this, di ba? Diyan nagsa-start. Okay? Pag E is equal to E naught, dito yung nagsa-start. Okay? Pero pag E less than E naught, dito siya nagsa-start. Okay? And alam natin yung behavior, ganyan lang siya. So, from zero velocity to maximum velocity, zero position, to negative position, zero velocity, di ba? And then zero position, maximum velocity. Okay? Positive position, maximum velocity. Okay, pero negative, di ba? Kasi nagpo-point siya towards the negative axis. And then, zero velocity, maximum position. Zero position, maximum velocity. And then, back to maximum position, zero velocity. Okay, so for E less than 0. Pero, pag nandito na siya, yan yung interesting na case. Tignan nyo ang nangyayari. Yan yung E greater than E naught. If we start at some angle, let's say ito yung angle na theta. No? So at some angle, sabihin natin dito tayo nag-start. Okay, anong mangyayari sa kanya? Mag-move siya towards sinasabi dito, mag-move siya towards the maximum position. Di ba? So nag-move siya towards the maximum position, which is this one. Right? Pagkatapos, meron siyang velocity, meron siyang angular velocity. Ito yung angular velocity niya. From a large angular velocity to a slightly smaller angular velocity. So mataas na angular velocity, pagdating niya rito, bababa lang ng konti yung angular velocity niya. And then, as it moves further, okay, paano nangyari yun? Na mag-i-increase yung kanyang mag-i-increase yung kanyang angular displacement. Well, it should. I think magja-jump ka ata dito sa Magja-jump ka yata dito pabalik. So magja-jump ka rito. Okay, and then, ito na yung iti-trace mong behavior. Okay, kasi from here to here, for example, nabawasan yung angular position, right? So nababawasan yung angular position, pero nag-i-increase yung velocity. Tama? Tama? Nabawasan yung angular position, pero nag-increase yung angular velocity. Papunta dito. Okay, pagdating dito, zero position, equilibrium position, maximum yung velocity. So maximum yung kanyang velocity dito. And then, pagdating dito, sa kabila, mababawasan yung velocity niya, dun sa maximum, meron pa rin siyang velocity, di ba? Hindi siya titigil na ganyan, tutuloy pa rin siya. So mangyayari is magja-jump siya dito. Okay, and then, ganyan. Okay? Okay, so ganun yung behavior nung plane pendulum. Now, I hope na mas ma-appreciate niyo yung ano tawag dito, phase diagram, kasi it will really, if you understand it enough, it will really tell you kung ano yung magiging behavior ng system. Okay? Now, ang mas interesting is pag meron ng randomness. Okay? Which we will tackle sa next meeting. Okay? So yun na yung chaos. Okay? Chaos. Okay? So yan yung i-discuss natin next time. Okay, so any questions?